So let's look at recognizing functions from graphs, as well as using our function notation with graphs as well. So in the first video where we introduced functions, we talked about kind of seeing how a graph is not a function if you can see an x value that has multiple y values. A shorter way of describing that is with this vertical line test, which is a way of just taking this test to a graph, and this will show whether or not it's a function. For short, you might see this as VLT for vertical line test. But the idea is if we go to our graph and we draw every possible vertical line that we can, if anywhere on that graph it intersects more than once, then the graph does not define a function. So let's see that in practice. That can be hard to listen to in words and apply. So let's see how this works. So this function here, what I want to do is imagine every possible vertical line that I can draw, and this is going to get messy, but every possible vertical line, I'm not even drawing all of them, just too many of them. But the idea is that with each of these vertical lines, and maybe all of these would intersect in this case. Sometimes it doesn't intersect at all. That's totally fine. When it does intersect, it should only occur in one spot. If it crosses more than once, that's showing that for one input, there's multiple outputs. But in this case, we're seeing just one intersection point for each of those cases. So this is a function here. With this case here, if I imagine my vertical lines, like that's good, good, good. Even right here on the y-axis, that line's okay. It looks like it's crossing twice, but because that's an open circle at the top, it's not actually defined there. So technically that's only crossing once. But if I go just a little to the right there, and this one I'll draw on here. If I go a little to the right, what I can see is for like near x equals a half, I have this positive output and negative output, and that can't happen. So this is not a function. For this case here, if I start drawing my vertical lines, cross once, 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 this is a function. And this last one here, and as soon as you can visualize where it fails in one spot, then it fails everywhere. So as soon as I can see a line about there where I have this output up here and output down there, then it's not a function. So that's our vertical line test for showing from a graph whether or not something's a function. Now, using our function notation with graph, so first thing we can do is determine whether or not we have a function, so whether or not we should even answer these questions. So if I imagine my vertical line test with this graph, we are all good. So yes, it is a function. If you're ever asked why, you could just say that it passes the vertical line test. So we could say it passes the VLT. All right. Finding values and solving for values using our function notation along with a graph. So finding h of 2, so this is giving me x equals 2 and I want to find what's the output. So what I would do is go to x equals positive 2 and just look for my coordinate. So I have this coordinate x equals 2, y is positive 1. So this function notation, h of 2 wants the output of 1. So we can see our coordinate format of x equals 2, y equals 1. H of negative 4, in terms of what that equals, I would go to x equals negative 4, and then I want to find my output on the graph. So I have this coordinate down here, which is the coordinate x equals negative 4, and we would have an output of negative 5. So my answer there is going to be that output of negative 5, or my y value. So with those cases, they're giving you your x value and you just need to find the y coordinate that's being mapped on the graph. solving h of x equals -5. So this is a case where they're giving us y. And we could have multiple solutions in these cases. So we want to make a list of x values, and maybe sometimes there aren't any solutions. That can happen too. But I want to start listing x values that have y coordinates of -5. And what can help to do that is to visualize. So we're at y equals -5. It can help to visualize a horizontal line and then just looking for all intersection points. So we can see we have this intersection at 4, -5. We also have this intersection at 0, -5. And then that's all of our points. So we're going to have two values for x. We're going to have x equals -4 and x equals 0. So with that, we could have kind of two notations. In fact, one of the notations will exactly copy what we see up above there, which is the fact that if we plug in -4, we get out -5, but then we could see if we plug in 0, we could get -5 in a different spot. Okay, x equals +3. I'm going to do the same thing. So I'm going to go to +3 on the y-axis. And then I'm going to visualize this horizontal line and look for all the spots where we intersect. And it's just going to be this one spot at 3, 3. So with that, I want to grab the x coordinate is going to be our answer. So x equals +3. So we have this relationship that h of +3 is equal to +3. So that's how we can use our function notation with a graph. It comes to reading coordinates. Just need to keep straight which is your x value and which is your y value and which are they asking for.